All right, so I'm going to try and make this video a little bit shorter than the others because we got a few more examples to go through. But we're going to look at some examples from section 1.3, which deal with graph interpretations, a problem-solving tool. So I'm going to start on page 24, and we're going to look at example 1. Okay, so if you're following along, example 1 right here gives us this garbage pizza. And so I'm going to recreate this table here, but and then I'm going to show you how we can leverage this to answer some of these questions. So I'm going to do this 13% food scraps. Let's keep going down the circle. Wood is 7%. Textiles, 5%. Miscellaneous, 4%. Rubber and leather is 3%. Glass is 6%. Oops. Metals, 9%. And plastics is 13%. Okay, so let's talk about this problem. We should know from the last video that we can insert a chart, and let's see what it gives us to start with if we need to edit it at all. Okay, we do not. So this is our pie chart, and it should look very similar. It's not as nice of a visual as the book, but let's get a little context for this problem. Let's move this out of the way a little bit. All right, so this problem says a project by the Illinois Environmental Protection Agency and the Waste Management and Research Center created a pizza, but not the ones with pepperoni, cheese, and jalapenos. No, they created the garbage pizza, illustrating the fact that each citizen of Illinois generates enough garbage each day to make a 5.5-pound pizza. If there are 13 million people in Illinois and each produces 5.5 pounds of garbage daily. So let's put that information just down below. 13 million people each make 5.5 pounds of garbage according to this allocation. So estimate how many pounds of garbage are produced each day. So this one's pretty simple. We're going to multiply these two. So if each person makes 5.5 and there's 13 million people. So what's kind of cool is I can take, I can say equals, right, 13 million. And then I can use the little star symbol that's shift 8 to say times by 5.5. And it's going to give me how much total garbage in pounds that is. So it looks like we've got 715 million pounds of garbage, or excuse me, that's 71,500,000 pounds of garbage. So that's our answer to A. Let's do this. Let's paste this here and we'll say A. Okay, B says, according to the graph, which category of garbage is the largest? So I think we can tell that that's going to be paper and paperboard. So I'm just going to say paper, and it is 40%. Use the answers from parts A and B to estimate the amount of paper and paperboard in the garbage. So the way that we would do that is you're going to take your total amount and you're going to multiply it by 40%. So what's cool is I can say equals, I'm going to take this value and I'm going to multiply it by this value. And it's going to give us that is about 28,600,000. I wonder if I should zoom in a little bit. All right, and then D says, which is the smallest slice of the pizza and what percentage does it represent? So if I'm looking at this, I see that rubbers and leather represent 3%. So rubber and leather, and it represents 3%. And then lastly, we're getting asked the same question, which is how many pounds does that represent for total experience in Illinois? So I'm going to say equals the total times the actual percentage, enter, and it ends up being about 2,145,000. Okay, so let's go to another example. Page 25, we're going to look at, whoops, I'm already there. Page 25, figure 1.12. I think I actually have this in another place. Figure, whoops, why are you scrolling? Okay, so we're going to create a bar graph out of this. So less than 5,000. So what the context is here is which is your household category? What is the oops, I have to go up a little bit further. Did your family save more money for your college education? How much? So this is a relationship between how much money was saved for college and the percent of household families that did save that. So I already pre-put in this information, and if I go to insert chart, we want a vertical bar graph, so a column chart. We're waiting for it to input that. And it gave us a circle chart, so let's change this to this. Okay, great. And then I think that there is a way so to emulate what we have here where data labels. Yeah, so if you click data labels, it adds those percentages just like we see. And that's that example. And then let's go to page, the next one down on this page, figure 1.13. So this information is the distance in feet at which brakes were applied. So this is a vehicle question. I'll let you guys kind of review the content of the question, or you guys and gals, and then you'll notice that it's age and activity. So if we did this again, whoops, why is it highlighting all of it? I just want this. Insert chart. And this time, what's interesting, I guess this one has it horizontal. So let's change ours to, there we go. And they have the labels in again. So chart style. Really, this is all about like getting the chart out there and then kind of manipulating what things you want to see and what things you don't want to see. So we've got these values out there. We have this, and it lets us kind of make interpretations of this. And it looks like the distance in feet at which brakes were applied is much closer for younger people, which is probably what you would predict. Okay, so let's go to page 27, and we're going to take a look at example 3. I think I might have this right here as well. Okay. So find the savings if you decide to pay the balance in 24 months. So what this is it's an example of a bar graph that shows you what a monthly payment would be corresponding to how many months you choose to pay off an estimated savings on credit cards. So the visual here is that if you choose, and this goes for if you get a car loan, and just about any loan. If your loan is longer, you're paying less a month, but you're paying more in the end. So let's go and insert a chart. And okay, so this is our chart. And let's say we want to customize series allows us to put in the data labels. Okay, there we go. So this specific example says, I'm going to move this over here. Find the savings if you decide to pay the balance in 24 months. Whoops. So if you decide to pay the balance in 24 months, all right, there we go. We're making a monthly payment of $50 for 24 months, right? So let's go and say equals $50 for 24 months. So that means the total cost is going to be 1,200. And we're looking for, if you pay $50 for 20 months, find the payment corresponding. Let's compare this to, let's do this. I'm gonna cut that and we're gonna put that right here. So this is the total. And so if we go here, I'm gonna go equals 12 months at $92. This would be 36 months at $33. Oh, that's interesting. $48 months. Is that just an estimate? Maybe I just estimated wrong here. Maybe it's like 38. I don't know. Looking at the graph, it's kind of an estimation there, right? If we do that, it's definitely more expensive. Interesting. Let's just say 34. All a visual. All right, and then here, 48 months at $30. Whoops. See, it doesn't like it if you don't hit the equals. Oh my goodness. There we go. And then lastly, 60 months at approximately $25. 60 months at approximately $25. So we see that if we compare the two values that this specific example is asking, we save about $300. Okay, one last example, 28, page 28, and we're going to look at example 5. Okay, so I put in an estimated data. So this isn't exact, but this is an estimate of what the visual we see is. So let's make a line graph out of this. Okay, so this should look really similar to what we have here. And this is what this shows is the new wind chill temperatures and old wind chill temperatures for different wind speeds. So, and let's customize it a little bit to look at these values. Wonder if you go data labels. All right, love it. And then chart style. No, I don't want the null. I want grid lines and ticks. Let's see what we get here. Oh, this will just show. So if you go to grid lines and ticks, it'll show ticks on the axis there, minor grid lines. And it just allows you to take a look at the y-axis a little bit nicer. So let's close this for a second and let's talk about these questions. If the wind speed is 90 miles per hour, what is the approximate new wind chill factor? So I'm going to make this a little bit bigger. And I'm actually what I would like to do is I'm going to take a snip of this and we're going to draw on it a little bit. Whoa. Okay, there we go. So we got this. This was from before. Let's get rid of that. Let's paste this. Okay, and layout. Let's make it a little bit wider. Make this a little bit bigger. Okay. So taking a look at this, it says if the wind speed is 90 miles per hour. And so 90 miles per hour occurs right about here. And so we've got these two. Oh, maybe I should use a different color since I've got right up there. Let's go green. So about 90 miles an hour. And we've got these two data values. And so this top one is our new. This is our old. And let's look at this question. It says, what is the approximate new wind chill factor? So we would say negative 30 degrees. B says, what is the approximate old? So we would have negative 41. And then when the wind speed is 90 miles an hour, what is the wind chill temperature difference between the new and the old? So when it says something like that, we think the new value is negative 30. And the old value is negative 41. And so we find the difference by subtracting those. So we're going to see a difference of 11 degrees, which you can also just find by finding this distance right here. And that makes sense to us because negative 30 is 11 degrees warmer than negative 41. And that is the last example I'll have. Please message me if you have questions. I'll see you all on Monday.